Makes me feel like a movie star. Not really. So it says here, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, here we have 2 times 2 times 2. So we can write that as 2, and we did it 1, 2, 3 times, so raised to the third power, right? And that's how we would write it. We had 2 multiplied 3 times, right? Parts of the exponential expression, the bottom part where we have the 2, or in this case the x, we call the base. The part that we're raising it to, the n that we have here, and in this case we had it as 3, we call that the exponent. Sometimes we call it the power, right? But its technical name is the exponent. And we read it as, like on this one, it would be x to the nth power, right? When we're reading it, right? If I read this right here, we would read that as x to the nth power. This we would read as 2 to the third power. Does that make some sense? You guys get that? So when we're looking at problems like this, we're going to write it. On your homework sheet, you're going to have a chart like this where you're going to have to fill it out. You're going to have to fill out the exponential expression and then the value. So when we write this, we know that 6 is the base. We've got 6 times 6 times 6 times 6 times 6. So we know that the base is 6, and we just have to count how many times it's being multiplied. 1, 2, 3, 4, 5. So it's going to be 6 to the 5th power. Now, I don't know what 6 to the 5th power is. I can go, well, 6 times 6 is 36, and that times 6, I don't know beyond that, right? So I have put for you inside your Google Classroom this Desmos scientific calculator, right? And if you'll notice, see here it says a to the power of 2, and then we have a to the power of b. If something is squared, if it's just to the second power, you could put it in using this button. But if it's anything other than 2, you want to use this a to the b. And we know that the number that we're putting in is 6, right? That's our base. And so once I put in my base, I could hit this a to the b button, and then I'm going to put in 5. And see, it's going to give me an answer for 6 to the 5th power. This isn't something you're going to be able to do in your head. When we're doing powers, the numbers can get so big that they're not something you can do in your head. You really do need a calculator to solve these problems. So this is how you would put it in. You'd go 6, and then you'd hit this A to the B button and put in 5, or whatever your power was, right? And we would get an answer of 7776. And so that is what the value is. The value is 7776, right? And so we're going to have to use this calculator pretty regularly while we're doing it. And we could go through and do these exponential expressions really easy, right? Here we have 23 times 23. So that's 23 squared. I don't know off the top of my head what 23 times 23 is. So again, I would go back to my calculator, and now this time I'm going to clear it, and I'm going to put in 23, and I can just hit the squared button, right? Leah, she's on top of it. She already got it, that it's 529. She's on top of it. I'm going to let her be my calculator person today. I need this thing to stop doing that with the mouse pointer. That bugs me. So, very important piece of information when you have See here where I have -3 times -3 times -3 times -3. Always make sure you keep those negatives in the parentheses so that when you square it or make it to the third power, in this case, right, we have 1, 2, 3, 4, so it would be to the fourth power. It's really important that you have the negative in parentheses like that, because if it was an odd number, say it was to the third power, this solution would come out negative. But we wouldn't know that if we were just if we didn't have it in the parentheses, right? Because it wouldn't be squaring that negative. So when you plug it in, even into the calculator, you're going to hit the parentheses -3 parentheses, and then we would raise it to the fourth power, and we'd get 81, and it would be a positive 81. If it was an odd number, like, see how this 4 is an even number. So if it was 2, 4, 6, 8, 10, 12, 14, 16, anytime the number that you're raising it to is even, we're going to get a positive result. If it's an odd number, you're going to get a negative result. Like here, you notice I put it to the fourth power, so it was positive 81. If I had the same thing, if I had -3 to the third power, we would get -27 as an answer. Anybody know why that might be? It's going to be positive 81, Leah. Think about this. What is -3 times -3? What's a negative times a negative? What is -3 times -3? Do I need to calm people? Yeah, Alicia's got it, right? -3 times -3 is positive 9. Now, if I took that 9 and I multiplied it times another -3, right? Well, 9 times -3 is -27, right? But if I took that -27 and I multiplied that times -3, I would get positive 81, right? Because a negative times a negative is a positive. So every other time that we multiply it, we're switching back and forth from positive and negative, right? Because we're not always multiplying a negative times a negative. So let's look at 11. Number 4, we've got 11 times 11 times 11. So we've got 11 to the third power. And 11 to the third power is, I believe, 1,331. Now, do I know that off the top of my head? No, I don't. I just happen to have the answer on a piece of paper in front of me. But we can plug that into the calculator and find it, right? You guys know how to use the calculator now. Here, I have -4. That's my base. We're raising it to the 1, 2, 3, 4 power, right? Do I know what -4 to the fourth power is? Heck no, I don't. I've got to come in here. I've got to clear this, and I have to put in parentheses, -4, parentheses to the fourth power. And I get 256. All right, we've got 2, 1, 2, 3, 4, 5, 6, seventh power. No idea what that is. I know that 2 squared is 4, and 2 cubed is 8, and 2 to the fourth is 16, and 2 to the fifth is 32, and 2 to the sixth is 64. I'm guessing 128. What happens when I have a fraction, though? And I raise it to the power. So here we have a base, right? Our base is 4/9, and we're squaring it. When we have a fraction like that that we square, we're going to square both pieces. So if I have, it's like saying 4 squared over 9 squared. So 4 squared is 4 times 4, which is 16. And 9 squared is 9 times 9, which is 81. Right? So when I have a fraction, I have to apply that power, that exponent, to each piece of the fraction, to the numerator and to the denominator separately. Does that make some sense? I'm waiting for some heads to go up and down or say no or okay, thanks. So again, here we have 1/3, right? So if I raise 1/3 to the how many power? 1, 2, 3, 4, right? That's the same as saying 1 to the 4th power over 3 to the 4th power. And when I go to give that a value, well, 1 to the 4th power is just 1. No matter how many times I multiply 1 times 1, I'm still going to get 1. And then 3 to the 4th power is 81. So this one, we can do -10 squared, and we know that that's just going to be 100. That one's not very exciting. What I want to talk to you about is sometimes you're not going to get the same value, right? If I have a, this is a to the 1, 2, 3, 4, 5, 6, 7th power, right? When I rewrite it as a value, it's still just going to be a to the 7th power because I don't know what the value of a is, right? So all I can write is a to the 7th power. It's not going to change for me. If I have 1 over x and I raise that to a power, we've got 4 of them, so it would be the 4th power. And when I rewrite that, that becomes 1 to the 4th power, which is just 1 over x to the 4th power. Sometimes you're going to get letters mixed up. Like here I have 2 m's, right? I have m squared times n to the 3rd power. And we could just write that as m squared n to the 3rd power. We don't know what the value of m is. We don't know what the value of n is. All we can do is write it to its power. And we could do the same thing here. We've got, I like to go in alphabetical order, so I'm going to write the p's first. I have 1, 2, 3 p's. So that's p to the 3rd power. And I have r, I have 1, 2, 3, 4, 5, 6 r's. So that would be r to the 6th power. And it's going to be the same over here because we don't know the value of r or p. Right? And we can do the same with C and D. I've got 1, 2, 3, 4 C's, so that's C to the 4th power. And I've got 1, 2, 3, 4, 5 D's, so D to the 5th power. And that doesn't change when we go to write its value because, again, we don't know what C, the value of C is, and we don't know what the value of D is. Make some sense? It's not too hard, right? Like none of it's too hard. You just have to count them. If there's a number, put it in a calculator and figure out what the number is, right? But if where they're just letters, all you can do is count how many of them there are and raise them to that power. Now we're going to talk about the square, right? We're starting with perfect squares. And the reason we're talking about it is so that we can do square roots, right? And it says the square of an integer is called, well, it's actually called a perfect square. The square of an integer is called a perfect square. Perfect integers are those whole numbers, but they can be positive or negative, right? And to start our first 10 squares, well, 1 squared is just 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, that's 9. 4 squared, 4 times 4, we've got 16. 25, 36, right? 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. We got the first 10 perfect squares there, right? It's really useful to know them. It will help you anytime you're doing square roots to know what your like smaller perfect squares are. The opposite of squaring a number. So squaring a number is multiplying it times itself, right? It's raising it to an exponent. The opposite of that is finding the square root of a number. And that means we're trying to find what number got multiplied to itself to make whatever's underneath this radical sign, right? So when I look at a radical, I'm going, okay, well, what number multiplied by itself to equal that number? So it helps to know what our perfect squares are. So if we look at this part right here, it says circle each value that is a perfect square. How do we know if something's a perfect square? Like we know 16 is a perfect square because 4 times 4 equals 16, right? And we have that one written right there as perfect square. So we know this one's a perfect square. But is there any number times itself that's going to equal 20? You can kind of look up here because you can see we go 16 to 25, right? So no number times itself. It would be something in between 4 and 5, but there's no whole number between 4 and 5 that it could equal 20, right? It would have to be something between 4 and 5. So 20 can't be a perfect square. Does that make sense? Now, it helps to kind of know your math. 81 is absolutely a perfect square because it's 9 times 9, right? So we could go ahead and circle that one right off the bat. Carson's like ahead of the game over there. So we know 20 isn't. What about 441? How would we know? I mean, I know that 20 times 20 is 400. So it would have to be something bigger than 20, right? So go to your calculator and check it out. I can go, okay, well, let's try 21 times 21. 21 squared, look at that, it equals 441. And so we know now that 441, perfect square. What about 225? Well, we know it has to be. I know what the answer is right off the top of my head because I know my perfect squares. I know it's a perfect square. But how would you find out if it was a perfect square? Well, we know 12 times 12, right? What's 12 times 12? Everybody knows what 12 times 12 is, right? It's 144. Desmos calculator really is the best tool ever. Well, 250 times 250 doesn't equal 500. Oh, but we're dealing with multiplication when we're working with squares. But you are right. 250 plus 250 does equal 500. We've got 225 though, right? That's what we're trying to find out. We know that 12 times 12 equals 144. So it'd have to be something bigger than 12, right? So let's look until we see if either we hit 225 or we go over, right? If we go over it without landing on it, then it's not a perfect square. So we know it's not 12 times 12, right? Because we know that's 144. How about 13 squared? Oops, it would help if I cleared that, huh? 13 squared gives us 169. That's still less than 225, right? Let's try 14 squared. 196, still less than 225, right? So try one more time. We're going to go 15 squared. Look at that. We land right on 225. Now, there's a little trick to this too. Like we've got 225, right? We can plug it in here and we can go 225 and we can hit the square root, but that's not how you enter it on this one. You could hit the square root button, put in 225 and see if you get a whole number, right? We just learned that the square root of 225 is 15, right? So we know on this one that 225 is a perfect square. We don't know if 290 is, but we can come back over to our Desmos calculator and we can put, clear, we can put in the square root of 290 and we don't get a whole number, we get a decimal, so it's not a perfect square. If we get a decimal, not a perfect square. So we're going to go back here and we're going to go, okay, what about 25? Well, we know that 25 is 5 times 5, right? So we don't even need to check that one. What about 500? Let's go. Let's go check it out. Just get it clear. Square root 500. Don't get, all we get is a decimal, right? Not a perfect square. Malia's jumping the gun. She's already like figured out that 30 times 30 is 900. So we're going to take her word for it, but we could plug it in too. We could plug in the square root of 900 and you can see that it's 30 times 30. So that's a perfect square. And it's really good to understand how to find these because that's how we find these square roots, right? What times itself equals 4? Well, 2, right? What times itself equals 361? I don't know that off the top of my head. I know it would be less than 20 because 20 times 20 is 400. So what, maybe 19, right? Well, let's look at that. Clear. What is 19 squared? Look at that, 361. So we could write that as 19. 169, 13 times 13. Can you use your calculator? Absolutely. 25 times 25. 289. I don't know if that's a perfect square. It's got to be, though, because they're asking you for the square root. So I would assume it has to be. I'm going to guess it's like 16. Ah, I was close. It was 17. I don't know what 16 times 16 is. I mean, 1600 is. I am going to take a shot and say that this is 40 squared. How do I know for sure? No, that's just my guess. So let's check it out. Clear square root of 1600. I was right. Why? Because 4 times 4 is 16. That's why I thought if it was going to be a perfect square, it would probably be 40. So when you're doing problems like that, use your Desmos calculator. See this part right here? I am not making you do it. If you look at the worksheet I gave you you're only doing problems up to this type right here. So there's no reason for us to go over this now. When we come back though from break, I'm going to kind of show you like how these break down a little bit. But when you do try and do them to the nearest tenth, you're just plugging them into a calculator to see what you get, right? You're just plugging in the square root of 90, and you're going to get a decimal answer. And to the 10th root, nearest tenth, that means you only go one past the decimal point to round it. So let's look at what you guys, let me stop screen castifying because there's no